You guys hear me? All right. Welcome to Working with Data at Scale. I'm Tom Larkin. I am the Senior Manager of Systems Engineering and DevOps at Snowflake. A little bit about me. I live in the San Francisco Bay Area. That's a picture of me and our dog, Booms. He is a good boy except when he's not, like every other dog. And I live in the Bay Area with my partner as well. And I've been in tech for 25-ish plus years. I started in Snowflake in 2019 as a solo CPE engineer. And between 2019 and now, I built the team out. And they eventually convinced me to be the manager last year. So now I manage the team that I helped build. And here's just kind of an agenda and overview. So hopefully this presentation makes a bit of logical sense. I'm just going to walk you through the life cycle of working with data. And this presentation is meant to be semi-interactive. So if raise your hand, give out a question or an answer, I'll ask some questions to y'all to see kind of where you guys might be at with data, but feel free to be interactive. Quick reminder, this is recorded, so if you say something out loud, it might be recorded, so just keep that in mind. So we'll be going over kind of about what my team does, working with data concepts, things like data pipelines and data modeling, and then data sharing, and then data consumption, which would be use cases and application of data and visualization of data. Here's an overview kind of just of my team, a little more in depth. We're globally distributed between North America and India. When I built the team, I purposely did not hire just a bunch of Mac admins. We have DevOps engineers, we have VDI engineers, we have mobile engineers, and Mac and Windows engineers. And so with a team of 7 people, we're able to accomplish a lot due to our diversified skill set. My team does manage every end-user computing device at Snowflake, which includes VDIs, phones, tablets, laptops. We don't really have any desktops besides a few minor, very minor exceptions. And then, of course, we work with data at every possible avenue that we can. And to give a little insight into our tool stack, everything you see in this slide is in production. We use GitOps where we can. We use Monkey and Gorilla, Jamf and Intune are our MDMs. We are a Google shop, so we manage like Chrome browser and things like that with Google. We have various data tools, Fleet, which is our OS query kind of management tool. FluentBit ships logs for us. And of course, Snowflake and Streamlit are products my company owns, so obviously we use those. And then Fivetran is a integration, data pipeline integration tool to Snowflake. Cloud stack and operating systems, pretty standard stuff. API gateways, Lambdas, S3 buckets, CDNs, things that most IT people in the cloud space work on. And operating systems, I don't need to really go into that. I think you all know what the operating systems are. And so let's talk about Snowflake. So what is Snowflake exactly? It is a cloud data platform which can support multiple data workflows that include, but not limited to, data engineering, data science, AI, ML, analytics, data warehousing, data sharing, so on and so forth. You can build applications on top of our platform now for data-driven applications. And kind of some of the unique things about Snowflake is that Snowflake is a product that has separated compute from storage. So in an old legacy classical data warehouse sense, you would just build this massive stack of compute in your data center, and all the compute and all the storage would generally be one stack. Snowflake has separated that, and so we did that for several reasons, but kind of the key benefits to the consumer, to the customers, is that you only pay for consumption. So you would, store your data in there, but you only get charged cloud credits when you actually run queries. So we separate that storage from compute. So it's kind of a consumption, kind of like a pay-as-you-go model, right? So the more you consume and the more that you query, the more that you spend, but that's up to your organization. So here goes some basic terminology about Snowflake, and this kind of tripped me up at first because when I first started at Snowflake, I had that old legacy on-prem kind of data warehousing mindset. So in Snowflake, a warehouse is simply your compute. It is a set of CPU and RAM, and it uses the t-shirt sizing model. So extra small to I think 4XL, I think is the range of compute that you can do. Changing a warehouse is literally a click in the application, or you can run a SQL query and say set warehouse to warehouse name. So you can literally go from an extra small compute to an extra large compute in about a few seconds. With an on-prem system, you'd have to procure the servers, you'd have to get them shipped, you got to rack them, you got to stack them, right? In the cloud, it's literally a button, right, that you get more compute. A data model, and data models are going to be a pretty hot topic today. I even wore my data model shirt. A data model is just really just a group of data sets that are in a single object that you can then query over and over and over again. And I'll get more into that later on. A schema is a logical grouping of database objects. And then a database is a grouping of schemas. So you have a database, and within a database, you have a schema. And within a schema, you can have tables and views. And that's kind of how it's organized. One of the things that people, always ask is like, well, how do I define the value of a tool like Snowflake? And so you get a lot of benefits from centralizing your data. Out of the box, these are pretty obvious ones, right? You get data governance, right? So how many people in here give other teams access to their MDM for like reporting? Right? And then you have to go in and like create the role for them, make sure it's read only, and make sure that you can't touch other settings. Well, we don't have to do that in Snowflake because we just tell them to go to Snowflake for the data, right? So, and then from there we can set rules like only these roles can access these datas through a role-based access control system. And so, I no longer have to go into like my MDMs or my IT tools and make all these read-only accounts for auditors and compliance folks. I can tell them just run the query in Snowflake, or I can give them a dashboard. And so that's a huge benefit. Like just the governance and access alone is a very huge benefit. And then once you get other teams' data in there, you can start sharing data back and forth. And that really drives like collaboration, and it can drive your organization from into a data-driven and data-enabled one. We have the marketplace too. So like there is a third-party marketplace where third parties can basically provide data. So you could go to the marketplace and purchase like IP info or some other set of data. It'll show up in your Snowflake account automatically, and you don't have to do anything, right? It's just there for you. When you get into using Snowflake, I just want to touch on these things pretty briefly. All of these bullet points could literally be a talk of their own, and I don't have time to deep dive into all of them, but SSO and SCIM, I really just can't think of anything that negative to say about either of those technologies. They're both amazing. Definitely, consider tossing your Snowflake behind SSO. Definitely look at setting up SCIM, and that means onboarding and offboarding access to Snowflake will be automatic. That's the beauty of SCIM. Multi-factor authentication and things like FIDO2, right? You can plug that into your SSO. We have things like network policies, which can manage ingress and egress access to Snowflake. So you could set up like a network rule to say only this CIDR range can connect to Snowflake, and then that could be like your VPN range or something. We also allow private link. So if you want to reduce attack surface and only do cloud-to-cloud networking, you can connect through private link. And then, of course, these are just non-Snowflake things, but password vaults, managers, conditional access, and of course, monitor everything, right? So if you're going to toss all your data in Snowflake, I really highly recommend that you look over these things and make your Snowflake instance as secure as possible. This slide is just links for all of the previous topics, right? So these are all just the official documents from Snowflake to set those things up. And we talked about roles earlier, and I'm just going to give a quick example of roles. And so in this little chart here that I made, let's assume that you have classifications of data like top secret data, non-top secret data. Maybe you have financial data, you have tech data, security data. Well, maybe you just want to give people read-only access to that. So you would just create a role, and you would name it, whatever makes sense, like, hey, this is a financial read-only secret data. And then you would give that role those permissions, and then users would assume that role when they authenticate to Snowflake. Data modeling role needs a bit more permission because you need to create tables and views if you want to be a data modeler. And then account admin is like God mode, right? It's like the root user. So maybe you only want to, one person to use that. Maybe you want to disable it and then use skim to re-enable it on demand. And then of course, data engineering roles, also a bit more permissive because they create data pipelines. So as you go in and start your Snowflake journey and you scale out access to your company, keep in mind that role-based access control is probably like the baseline to secure access to data. This is a question that I get asked a lot on LinkedIn and Slack and sometimes at conferences. It's more like, well, if I get Snowflake, how do I use it? Like, how can my organization use Snowflake? And I have opinions, and these are opinions, not facts, so keep that in mind. But I would say that if I was an executive at a startup and I'm building out a data-enabled, data-driven organization, I would say every department gets their own database. And then every team has a schema within that database. So for example, I work in IT, and I'm on the platforms engineering team. I'm in the IT database. My team schema is platforms engineering, and within that schema, all the tables and all the views of the data that my team owns goes there. I would use a lot of the RBAC stuff we just talked about, and then I think I mentioned this like a million times in this talk just to like really hammer it in. Data owners and subject matter experts are going to be really clutch when it comes to working with data. So I'm just going to make an assumption. Everyone in this room is probably some sort of Apple device admin, right? Because this is a Mac admins conference. That means all of you are domain experts at Apple, right? So when you ingest like the MDM data from your MDM, you're the expert on that. You will be able to define what that data means. You can tell other teams what it means. And you really just need to work with other people and other domains and always let the experts be the expert. The other question I get a lot is, well, who should manage Snowflake? This is also on my, on my LinkedIn posts. I have opinions, again, this isn't a fact. I think data engineering teams are probably the best candidates to manage Snowflake. They already need privileged access to build data pipelines. They're usually extremely knowledgeable about data and data platforms. But it doesn't mean IT can't manage it. So it's really just relative to your organization. But I do get this question quite a bit. So now we're going to dive into just kind of some data logic and data concepts of working with data. And this is something that I iterate every time I talk to someone who's just starting out. So you must be okay with being wrong, and you will be wrong a lot. A lot of things that you thought you knew over the years, once you start understanding your data, you're going to find out you were doing things wrong. it happened to me. It was kind of a revelation. I've changed my point of view and my approach to device management a ton after having this data in Snowflake. And the great thing is the data is going to tell you kind of like where to go and what to focus on. And then the last thing I really want to like kind of just throw out there is like there are a ton of biases. Sometimes you're not even aware that you're being biased. I highly recommend doing a brief web search of biases, and look, there's like hundreds to thousands of different types of biases. Just be aware of them because you want to be as objective as possible working with data and not be biased. Going back to my let the experts be experts, right? So I won't go over the bullet points, but I'll give you a little story. So back a few years ago, we were trying, or my compliance team at Snowflake was trying to track MDM locks. And they built this dashboard with all these queries, and they're like, Tom, we figured it out. And I'm like, oh, I haven't even sent you guys like the info yet. That's cool. Turns out they were querying the activation lock data from our MDM. And I think everyone knows that MDM lock and activation lock are not the same thing. And so, you know, and it's not their fault, right? They're not MDM experts. They just saw the lock and they're like, oh, that's the data. It's not. And so this is really just about, you know, respect people of their expertise and their domain, collaborate with them, and, you know, share your knowledge. And then data-driven versus data-enabled. This is another thing that is just kind of a little gotcha. So I think data-driven is pretty self-explanatory. It's the ability to make decisions off of data, right? I think most companies and organizations want to be data-driven, but data-enabled means you have the skills to work with the data. You do not have to be data-enabled to be data-driven, but someone at your org has to be data-enabled to allow people to be data-driven, which goes into my next slide of basic data skills. SQL and Python are all over the data space. They're all over machine learning, AI, big data, data analytics, data engineering. I highly recommend learning both SQL and Python. Just in general, because Python's like a very transitive skill. You can transfer that from data to Mac OS automation to Linux and cloud automation. And then SQL, well, there's SQL-like databases everywhere, right? So if you do have some SQL skills, those two things are transferable as an IT professional, in my opinion. Understanding your tech stacks, you guys are already the experts. Y'all are the experts at Apple device management. You know, just make sure you keep learning and keep understanding the tech specs and the domain expertise. Always work with other people that are SMEs. Like, for example, I don't work in security. So when there's a security data question, I go to the security engineering team and I say, hey, please describe to me how this data works, and they do. Also, as an organization becomes more and more data-enabled and data-driven, you kind of want to set some standards, right? So like define sources of truth, define desired states and baselines, learn how to filter out through noise with data, and, you know, share data, right? So we share almost all of our data with security. Security shares a portion of their data back just due to like privacy concerns. But I have access to like CrowdStrike agent data, Nessus vulnerability data, and things like that, Code 42 DLP data. And we use that data to track agent health. And we only have that data because the security team has shared that data within Snowflake back to us. And context matters, right? So this is kind of just at a glance how we approach data on my team for the most part, right? So Jamf and Intune are our MDM sources of truth for Mac and Windows, right? ServiceNow is our asset tracker. We ingest all the ServiceNow data. Security agent data, I just mentioned the security agents, right? We have all the telemetry and Snowflake from the security agents. And then we have HR data. And I want to be clear on this because when I say HR data, people go, oh, you can't have that. That's private. And I'm like, it's directory data. So at most companies or organizations, you have a company directory. You can look people up. You can see their position, their job title, their manager, blah, blah, blah. It's like an org chart, right? That's what I'm talking about. That type of data in Snowflake is very valuable. And then, context matters, right? So, I've had this this back and forth with our asset team at Snowflake, and it's more like we're just trying to solve a very difficult problem, and they want to do ServiceNow Jamf integration and auto discovery and auto asset creation. Well, what happens when IT people spin up 50 VMs over a summer of beta testing, and then those VMs get automatically ingested into ServiceNow, and they're not real devices, right? So MDM is not an asset tracker. MDM is only good for MDM data. And so, we kind of like to define that stuff. A context could be our CIO made a statement a couple years ago, and he says every full-time employee is required to have a primary asset in ServiceNow, right? That's a hard requirement from our CIO. So we use that as a baseline standard when we create dashboards and data sets, and we try to fix our asset data. And we get all that data from data sharing, right? I don't own ServiceNow. I'm not a ServiceNow expert. The ServiceNow team has shared that data with my team. Now let's go into some data pipelines. So yes, that is data smoking a pipe going through a pipe. Data pipelines are really just kind of a end-to-end process where you're taking data from a source and you're shipping it to a destination. And then in between that travel, there could be some transformation, like data scrubbing, data cleaning. It really just depends on what you want to do. But data pipelines should be automated, continuous, and extremely reliable, right? So when you build a data pipeline, make sure you kind of follow that as a baseline. The data pipeline tools we have at Snowflake, we have Snowpipe, which allows you to stage data in cloud storage. So if you can get data to an S3 bucket, Snowpipe will just consume it. We have Snowpipe Streaming, which is a non-staged data ingest. It just streams the data directly. So the big difference is if you need low latency, fast data, data streaming is probably the answer for you. It's probably going to cost a bit more in compute because it's just a continuous fire hose, where Snowpipe is staged and it's consumed on event. And then we have tasks. Tasks are, for lack of a better description, like a cron job. You create a task, you can say, I only want this data once a day or once a week or whatever. And that may work out. So it's very relative to your use case. It's case by case. We do have third-party tools like Fivetran, and we have tons of more. I just mentioned Fivetran because it's the one third-party tool that I use. And now we talk about ETL, so extract, transform, load. This is a very common term in data pipelines and data engineering and stuff like that. It just means that you extract data from a source, you transform it into whatever format you want, and you ingest it, and you load it into your data tool. You'll see all of this. I literally just copied the Wikipedia description, but if you want to read up on it, it's pretty useful to know. And then this next slide is ETL versus ELT. It's the same thing. It's different order of operations. The difference is where you want to transform the data. So almost everything that I do, I ship the raw data to Snowflake, and then I do all the transformation in post. But I don't have any regulatory needs of stripping out PCI data or something. So if you are a bank and you're ingesting PCI data, you might want to do a transformation first to strip those private data bits out before you ingest it. And to make this even more complex, Snowflake has tools like data masking, so you can ingest it and then mask it with Snowflake, but that's really kind of probably beyond the scope of most IT teams, but it's there. And then here's an example of a data pipeline. So we use Fleet for our OS query management and orchestration. Fleet can firehose Kinesis stream query results to an S3 bucket, and then I have Snowpipe consuming data from that bucket. When I enable a query in Fleet, I get data in like 3 to 5 minutes. That's how fast it is. It's pretty instant. And let's just go through a breakdown of that, right? So if you all didn't see the Fleet demo yesterday, they have a booth here. I'm a fan of their product, obviously. We use it. But so basically, when a query executes on an endpoint, it outputs a JSON file. That JSON file then gets streamed from Kinesis, via Kinesis, from Fleet to an S3 bucket, and then an SQS event goes out to Snowpipe and says, hey, the bucket's been written to. Snowpipe goes, all right, let me go consume the data. So it's an event-based data pipe. It's pretty fast. It's pretty robust. And to give you kind of an insight, I have a data model for like every process running on the Mac because security is like, I want to know every process running. It's like 15 billion rows of data already. And that's just one data model. And we get that data super fast. And then webhooks, right? So Fivetran is the webhook tool we use. Jamf Cloud. When an event happens in Jamf Cloud will ship a webhook. That webhook is shipped to Fivetran, and then Fivetran has a native connector. And the great thing about this is, I'll give you a little story. We used to use a different webhook data ingestion tool. That specific tool got acquired by a very big company, and they just sunset the tool because that company was going to roll that product into their product. And so I had like 30 days to figure out where to ship webhooks. But we also had Fivetran. I had never used Fivetran in my entire life. I didn't even know what it was. And they're like, here, figure it out, Tom. Within 30 minutes of not ever knowing what it was, I had webhooks shipping from Jamf into Snowflake with Fivetran. So I would say that it's pretty easy, since I didn't even know what it was, to 30 minutes later having it working. And so the webhook events that we ingest is like inventory, policy complete, device check-in, dep additions, device add, API operations. And I don't remember if Jamf added the webhook for the new API. I know they only used to do the classic API, but I think they've added this to the new API now. I think they have. And so this is kind of just a breakdown of how this works, right? So a lot of this is review from what I previously said, but the takeaway on this slide is that Fivetran does a sync. So it'll collect webhooks for a specific amount of time. I have it set for 5 minutes. So every 5 minutes, it syncs those webhooks with Snowflake, which means when a webhook event happens, I get it in about 5-ish minutes later. In Snowflake, which is fine with me. I don't need these instantaneously, and I think 5 minutes is acceptable for my use case. If you really needed them in real time, you could look at like streaming them through like a Snowpipe stream. I think that's overkill for my use case, but my use case is not your use case. And so let's take a look at Fivetran. So if you log into Fivetran, this is the interface. You can see at the top here, I just did a webhook search. The first top result is webhooks. And Snowflake connector is pre-configured here. I didn't configure it, data engineering did, so I don't know how they did it, but it's a native connector. And if you go into the webhook, this is the schema. And as you can see, if you're familiar with, who's familiar with Jamf webhooks here? All right, a few people. So there's basically 2 high-level JSON keys in a webhook. There's an event key and a webhook key. And Fivetran splits those top-level keys into columns. And then here is the scheduler, right? As you can see, I built this in 2020. My name's on it right there. and every 5 minutes it ingests. And these are like the 3 little interfaces that you deal with Fivetran, and that's it. You'll generate like a URL, and then you'll go into Jamf and feed that webhook setting that URL. And so that's another way to ingest data, is like webhooks. And then API ingest is probably the most complex one, because you have to deal with like authentication tokens and API clients, and you have to write code. You also have to worry about rate limits. Like if you ever dealt with Okta, you know about rate limits. And so you just gotta be mindful of these things. And typically, this is my opinion again, serverless compute in the cloud is perfect for this. Like a Lambda function or an Azure function. Just write some simple code with like a secrets manager or a secure parameter store. Have it ingest your API data. And just, again, if you can get it to an S3 bucket, Snowpipe can just consume it. And let's do a quick overview of the data pipeline section. So has anyone in the room done any data pipeline work before? Oh, all right, at least one person, nice. Who here actually has data from like their all their apps and sources going to like a data warehouse? Anyone? Oh, all right, that's awesome. There's actually more than I thought. So data pipelines just have to be automated. They have to be continuous. They have to be highly available. You have to monitor them because we've all heard that story, right? Or that saying, garbage in, garbage out, right? So you just got to make sure that that's the case. The good news is a lot of these modern tools make that a lot easier than it used to be. And then kind of the webhook and API and data streaming, just kind of a quick overview. Webhooks are great for event-based data because typically some sort of event happens and it kicks off a webhook. And API is generally if you want the full data set because webhooks never ship the entire data set. And then data streaming versus, a staged ingest is just basically on your need to how fast you need the data. Okay, another question I get all the time is, I don't know where to start. What type of data should I ingest? So I've built a starter pack. And those are the 4 categories I recommend that are a very great place to start with data ingest. All your MDM tools, all your IT operations tools, and then have security do all of their tooling. You need asset data. I can't stress this enough. Asset data is probably the most fundamentally used data set here at Snowflake. It filters out so much noise, and when we get to the data modeling section of this talk, I'll go into it. So start with these, and then the other question I get all the time is, well, how much of the data should I ingest? All of it. Give me all of your eggs and all of your bacon, right? And just ingest the raw data. Because if you try to be clever and only ingest pieces of data, some director or VP is going to be like, oh, hey, could you make this data do this? And you'll be like, well, now I got to go edit the pipeline because we're not collecting that. And then people are concerned that, that's too much data. And IT operations data is not big data. It's just a collection of a bunch of tiny pieces of data. I think we had like 300 million webhooks ingested when I spoke at JNUC. So we're probably close to 400 million webhooks at this point. I think I have a couple terabytes of data ingested, and that's like everything. And we're talking that's years of data. And a couple terabytes of data in the grand scheme of a big data tool is nothing. Unless you're hitting multiple petabytes, right? It's not a big deal. But I think people in the beginning kind of freak out. They're like, oh, it's too much data. It's like, no, it's actually not that bad. And then here just goes some considerations to kind of think about when you get into data ingest, right? And all of these things I've kind of gone over. It's just kind of a review. And As you grow your data story at your organization, you'll end up having hundreds of pipelines, right? So you'll also want to think about, how do I monitor my data pipelines? And you can do that in Snowflake. It also really helps if you have a really good data engineering team. So I'd recommend you build a data engineering team at your organization as well. All right, now we're going to talk about data modeling. So what is a data model? Well, it's just really combining multiple data sources into a single object for a specific use case that you can consume over and over and over and over again. And then within Snowflake, we have a feature called views. Views allows you to turn a query into a virtual table. This is a really nifty feature, because if you can query it, you can create a view out of it. And then views, since they're like a virtual table, can be shared to like roles. So like going back to the role-based access thing, I can like create a view and then share it to the security engineering role if I'm sharing data to security engineering, for example. So I don't know if you can see this code or not, but this is an example of a view. What view is this? This is my OS query view for all of the Mac OS applications we ingest. And so I'm going to break this down here real quick, right? So at first, we want to create or replace the view. Just know you can never modify a view. You can only create or destroy. And so on the previous slide, I didn't have that copy grants. That copy grants is important. If I'm updating a view and I don't copy grants, well, now I've created a brand new view and no one has access to it. And now I got to go reapply all my grants, and it's kind of annoying. Ask me how I know, because I've done this before. This part is really just naming the columns, right? So as you get into your data modeling, kind of, journey, sometimes you'll have like a table, like ServiceNow has like an ALM_assets table. Anyone know what that is? Yeah, no one does, because ServiceNow has 1 billion CMDB tables, and only ServiceNow experts know that stuff. But so I might want to call that something else. So these are kind of like the names you want to name the columns to make sense. And then here is the query. So if you take that last part of the select all the way down, that's just a query. I can run that in Snowflake and get results. I just turn that query into a view by doing that. And now I can share that view and it can be consumed by others. Okay. So this is probably one of the best quality of life features for IT people. Semi-structured data support, which Snowflake classifies as a variant data type. It means you can just natively ingest like JSON and XML, and you can just natively parse it right in Snowflake. And then, of course, you can, since it is a data type, you can typecast it into other data types like strings, integers, booleans, so on and so forth. And then here is a OS query output for Firefox extension collection. And you can see that it's just a JSON file, right? So we get thousands of these probably a minute from, or maybe tens of thousands a minute from Fleet through our Kinesis stream. And so when you go into this, right, how many people are familiar with like simple Python dictionary parsing? Okay. So when you look at this, you'll see that I'm using a built-in feature of Snowflake called lateral flatten. And if you go back here, you might notice that the top level key of the query result is called snapshot, right? And so here, I actually put that in its own column called snapshot. And so I flatten snapshot as f, and I can just call f.value, and it's just like parsing a dictionary, right? give me the value of this key. This key should be a number, and I want to name it the auto update underscore status. This is a huge quality of life feature for IT because we deal with JSON and XML from like every API out there. Now, if we go into a little bit further here, I kind of have just a bit notes here that kind of break it down. And I use flatten so much because almost all my data is JSON. It's just a huge quality of life feature. You don't have to do any special transformation. You don't have to do any regex or grokking or any of that nonsense. You can just ship the raw JSON right to Snowflake, and it just works. And this is just kind of a little breakdown and kind of just a benefit. Like I said, it's a huge quality of life feature. It's so common that I think like every single API I deal with, like a REST API, is just all JSON. Everything's JSON. So it just makes it super easy to use. It also means you can just data pipe the raw data of JSON into Snowflake, and you're done. So ServiceNow, how many people have an asset management system? How many people have an accurate asset management system? Yeah. All right, man. Well, keeping asset management data accurate is an extremely difficult task. And I don't think anyone has solved that problem on the asset management side. But what Snowflake can do is Snowflake can really help you get to that 100% accuracy. And so, going into ServiceNow, right, there are so many CMDB tables. It is a very confusing product if you don't live and work in that ecosystem. And I have to constantly go bug the ServiceNow experts at my job because I don't understand the product. And then they kind of guide me on how the CMDB works. We also have an integration into ServiceNow from our HRIS system. And that allows us to map if they're a VP or a VIP or if they're on leave of absence. So the fact that you can do that in ServiceNow means that all those enhancements upstream, I get that data downstream when it's ingested into Snowflake. Here go the tables and the CMDB tables that we leverage to build the model. So I don't know if this is 100% accurate either because I'm not a ServiceNow expert. So if you download this slide deck later on and try to model this and it doesn't work, I apologize. However, I will have one of my ServiceNow experts at my job correct me, and I will give you the proper info. I think it's pretty accurate, though. And so, again, right, collaborate with SMEs. Let experts be experts. Go talk to your asset management team. They are going to know the tools that they use better than anyone else because it's their tool. And this data is so fundamental because we use it for filtering, right? So in ServiceNow, we have out for repair, in stock, a testing unit, e-wasted, retired. We have these statuses of assets. I get to filter all non-production systems out by joining my queries to ServiceNow. So again, sorry, this is a lot of code in a tiny slide, but this is the data model for the ServiceNow assets. As you can see, I'm just joining a bunch. These are all CMDB joins. And I'm joining the ALM asset table, which is meaningless to most people. So I named the columns something a bit more human readable. And the great thing about this is the underlying data can change, but you can keep the alias the same. So if ServiceNow comes out with an update and they change the tables on you, well, you, as the owner of the data model, might have to go do a bunch of magic to make it work, but you can alias it so the columns don't change, so everyone's queries don't get broken. Because if you go change the column name and there's say 100 different queries running against that data model, you just broke 100 queries. And then here's our return, right? I kind of went over this already, but obviously, you get a huge return on putting effort in around asset data. And I use asset data a ton. And here's an example of the data model that you just saw of how I'm using it. This is Jamf data and ServiceNow data and HR data right here in this data model. I have highlighted the joins here and the filters. So right now I'm joining it by serial number. So the primary key between Jamf and ServiceNow is the serial number. So I can join on serial number. And then I can say, only give me primary and secondary systems, which filters out all the other junk, right? Retired systems, repaired systems, e-wasted systems. Your MDM has no knowledge of this, right? This simple query gives me the exact data I want, and it gives it to me pretty quickly. And then that query that you saw, I actually wrote it for an engineering director, I think, maybe a manager. I don't remember if he's a director or a manager, but engineering was doing their Intel to Apple Silicon refreshes, and the manager was like, I want to track everyone in my organization that doesn't have an Apple Silicon. So I just went to the Jamf data, grabbed the hardware information, joined it to ServiceNow, joined it to HR data, made sure that they were still working at Snowflake, they were still employed, making sure they're in the engineering department. And now I don't have to email a CSV. I don't have to give this guy access to my Jamf instance to run a report. They can just run that query on demand and get the return, and then he can filter it for Intel versus Apple Silicon. And that's how they were tracking the hardware refresh from Intel to Apple Silicon across the engineering department. So that's just a really neat way to like give someone a one-off query and be like, hey, you don't need to Slack me anymore or email me or call my phone anymore, because run this query, it'll give you the updated data and you can run it on your own. So you're enabling people to go get that data on their own. And now we're going to talk about data sharing. Data sharing is probably another just a fantastic way to collaborate cross organization. We data share, so like for example, HR data shares to us, security, other IT teams. And this data sharing means that you can just select the basic pieces of data that you want to share and nothing else. So maybe I don't want to share the in the weeds IT data to like a manager, then I just won't select it, right? And I'll build a query or a data model that just shares just what I need, which I kind of just went over. So, in this slide. So, again, right? It's just a great way to enable people. I can't tell you how many times I would get annoyed at previous jobs where I would say, hey, I need this data for a project. They're like, let me run you a report. They'd email me a CSV. And then by the time I could actually get it done, it'd be like 4 days later. And I'm like, well, now I need a new CSV because the data is stale. I don't want to do that ever again. You can just data share in Snowflake. The data marketplace, right? Again, you can get third-party data. You can also ask your vendors, I don't want to ingest your data, Mr. Vendor, into Snowflake. I want you to data share my data back to me. So you can do like account-to-account data sharing as well. And so we have a vendor we use called Beyond Identity for like conditional access and MTLS passwordless SSO authentication. And they data share our data back to us, so we don't have to maintain a single data pipeline. We just have a database that shows up in our account with the Beyond Identity data in it. And now we're able to parse that data and consume that data, and we don't have to spend any effort on the pipeline because we've told the vendor that's their responsibility. All right, now the fun part. Leveraging Snowflake with use cases and takeaways and workflows and returns. So I start with a general guideline, right? I love filtering data, but never ever throw the data away. Contextualize that data in specific buckets. That will help you in the long run because you'll get a side-by-side comparison. Also, it's just kind of a bad practice to do like the sweep it under the rug method, right? If you filter it out, the data is still there. You're just not viewing it. And then, spot check your data, right? Go into Snowflake and say, hey, does this data match my application data? And that's just to make sure that the pipeline is accurate, right? And then I think for like the 10th time this talk, let the experts be experts. Go talk to your SMEs, become friends with them, data share with them, and then let them guide you on what their data means. Don't make assumptions. So tracking MDM telemetry. The problem statement is we all know MDM products fail, right? How many of you have written like scripts and launch daemons and all this crazy stuff locally to track an MDM? Yeah, a few of you. All right. Right? How successful were those endeavors? 100%. 100%? Oh, wow. Wow. Well, I think you should go build a product then and sell it because I've never heard that before. So I've changed my approach on this working at Snowflake, and this is the you will be wrong and that's okay, right? And so what I've kind of done is I've changed my mindset and I've said if a Jamf client is not shipping telemetry to Snowflake within a certain amount of days, that Jamf client is in an undesired or broken state. I don't have any local launch daemons. I don't have any clever scripts. I don't have all this crazy engineering effort and logic to run on local devices. I simply just look at the last time a device shipped a webhook, and if it's over like 20 days or whatever the arbitrary days that we set, we call that a violation, and then we have integration into Snowflake where a ServiceNow ticket automatically gets generated and assigned to help desk to go help that person, because typically you got to reboot the computer. That's like step one. So we're not going to automate reboots. That's a chaotic evil workflow. We instead open up a ticket and have the help desk walk through, like can you reboot your computer, and if that doesn't work, can you re-enroll your system? And the example is, this is a common table expression, so it's a CTE. This is probably some of the most complex queries I write. So literally, this is the complex SQL you might have to learn to use this. You will need to put some effort in to learn something like SQL or Python to do this, but that's about it. It's not too difficult. You can get there. And what this does is it joins ServiceNow to a Jamf webhook. It only cares about primary devices because I actually have two buckets. I have one for primary, one for secondary. And then it joins the HR data to make sure that their last day of work is null. Because if you don't have a last day of work, then you still work there. And then we're at the bottom there, you'll see I'm doing what's called date add. And so basically I'm saying if it's 30 days past the current timestamp, that's a violation. And just a quick breakdown if you're not familiar. Every time a device submits inventory to Jamf, it ships a recon webhook. I found this to be pretty heavily reliable. Really only broken devices don't ship webhooks. And we have a crap ton of webhooks ingested. And so, again, this is, I think I duplicated this slide. Let's skip that. So here is a visualization, right? As you can see, we had a really good flat run there where no MDM agents broke for a while. But sometimes OS updates come out, right? And OS updates sometimes kind of trigger some sort of state where the MDM agent gets all, messed up. And these are failures per day. So the worst day we had 10 failures. We've got just under 8,000 max. So 10 failures out of 8,000 is actually not that bad, right? But this is just me trending that failure over time. And here goes the actionable workflows that we have. So as we've gone through this talk, we've gone through like the basic concepts of data. We've gone through creating a pipeline, right? And then creating a data model. And so now we're at actually consuming that data model and taking action off of it. And you know, we can off a query result in Snowflake, we can then DM the user on Slack, right? So maybe it's like, hey, can you reboot your computer, please? And if not, we'll open a ticket, right? We can automatically open a ticket. We are looking at building integration into the auto re-enroll API in Jamf. We haven't done that yet because we're building our middleware automation stack to do that integration. So we're kind of blocked by not having that integration yet. So these are just like the actionable items we get from all the work we've done with data so far. So OS patching. How many people here have SLAs for patching? Yeah, quite a few. All right. How many people use Nudge? Yeah, I figured. And then I'm assuming that has greatly increased your compliance, and it has made kind of like your workflows just in general better, right? So the problem statement is, how do we make everyone's laptop on the most current OS, right? And our solution is Nudge, but before Nudge existed, we were using the software update binary. I won't go into too much detail. I think everyone has had enough pain and suffering around the software update binary, and to give Apple some credit, they've improved it since the Intel T2 chip era. It still has, some polishing to do, so we still use Nudge, but that was our solution, was Nudge. And so I have this historical data. This is pre-Nudge data. This is back when the software update binary was really just in a bad spot. And as you can see, there's a lot of yellow in that chart. And that means that OS adoption just wasn't really great. So what we did is we, looked at the historical data. I'm sorry, this is actually post-Nudge. So post-Nudge, we went back and viewed the historical data. So retrospective data kind of querying can be very useful, because not only does this prove that Nudge is like an amazing tool, it justifies our decision. And so going back in time to look at historical data for the stuff you've done can really help prove or disprove the return on your effort. Another example is my previous talk at JNUC on this, I built a dashboard that tracked all self-service policies, right, through the policy webhooks. We found out that less than 1% of our policy execution comes from self-service. So that tells me as a manager, don't waste resources on self-service. If people aren't using it, don't have my engineers spend tons of time on it. Instead, focus on automation, because automation was 99.9% of our policy results. And this is post-Nudge. This is a much prettier chart. Also, Snowflake is a much bigger company now, so the chart got bigger. But as you can see, as an OS comes out, one color pretty quickly dominates the charts, right? So this proves that over a 90-day period, Nudge has a huge return on value. It has definitely increased our patching. Our engineers have now done some automation with it, so we got a good return. And the historical data kind of shows us we weren't doing it the right way back then, right? And then here's our OS dashboard all put together. So, right, I'll just go over the panels here on the top left and then going right. Those are termed employees, right? So those are employees that have last days of work in their HR data. I filter them into their own bucket because typically when you exit a company, you ship your laptop to IT or whatever, and there's like a period of time that takes. Sometimes it takes a month or two because of distance and people in other offices. And also, I don't want to ignore the termed employees. However, I don't want them in my production data, right? So this is that filtering it into a separate bucket. That next column is production data. So that's all the production max. You can see we're heavily, vastly on 14.5. And then the blurred out sections are just text versions of the visualization. So you can just search those by whatever key term you want. At the bottom left there, we do OS by department. So now I can say which departments are struggling to patch and why. That middle one there is leave of absence. So you might have an organizational policy, and or if you're a global company, some countries have laws stating you cannot contact someone on leave of absence. So again, I don't want to filter those out and get rid of them. I want to contextualize them in a bucket so we know that there are some people on leave of absence and their laptops may not be patched because they're not working. And I kind of just literally explain these key takeaways in the visual, so I'm going to skip this into the next slide. So problem statement. At the beginning, we had just MDM data. A lot of you will probably know that MDM data isn't the full picture. It's just MDM data. And so our solution was to use OS Query, right? It's a cross-platform data collector tool, very robust, has lots of neat things about it. And we chose to get a product called Fleet, which I've already discussed. And here go the use cases, right? Application data, performance data, security data, application usage, and then like MDMs can't collect browser extensions, right? And we need that data for security because browser extensions have vulnerabilities. And so here goes one of our use cases is, who uses Monkey in here? Oh, wow, quite a few. Are you all familiar with Monkey's application usage database? Awesome. So we used a feature called ATC, auto table creation. And the idea is we want to better manage licensed software, especially expensive licensed software. So this is kind of where we went. I wrote a blog post about it in depth, so the link is there. How to set it up, how to use it. And so I'll just go to the next slide. So Monkey uses NS Workspace to kind of get that data. It has 3 specific events it tracks, right? Launch, activate, quit. Pretty self-explanatory. The thing to note is activate means to bring the application in the foreground as the most foreground application. This is how we track application usage. So if you look here, this is all the events by Adobe Apps. And remember, all that work I did with the data pipe and the data modeling, now look at that query. That query is like a one-liner. Now, all that work I've done is paying off, and I can write this one-liner and say, hey, give me everything with a bundle ID like com.adobe. And as you can see, Adobe Reader and Acrobat Pro are the most used applications out there. Now, further going into that data, right, here goes everyone who has Illustrator that hasn't launched it in 6 months. So there's about a dozen or so devices on here. The query, again, not too complex, right? So I'm getting that big return off the pipeline and off the data modeling. It's a pretty simple query. And what we're going to do is we're going to go revoke those licenses. We're going to save money. And the user experience will be, if you needed that license again, open a ticket, we'll give it to you. But the second you stop using it, we'll take it back. And then asset data fidelity, right? I've only got about 11 minutes left. So I'm going to go through these last slides so I can get to Q&A. Asset inventory data has to be 100% accurate. There's no option. There's no other option. So using Snowflake to kind of augment this problem and solve it has been extremely valuable for us. So as we know, auto discovery and auto asset creation creates garbage data. MDMs are not asset systems. Sometimes humans have to manually input data into asset systems. So they might, slip on a character, or they scan it and you get that great leading S from the barcode on the box, right? And so you just have things like that, and then data drift and things like that also happen. So again, we use agent telemetry. I don't use any of these fancy extension attributes or scripts or anything. Hey, if a device is shipping data to Snowflake and that device isn't in service now, right? That's a violation. And here's the query, and there's the visual. So, just last month, we bought about 20 laptops from a vendor, and somehow they got enrolled and got into end user hands before the asset records were created in ServiceNow. And literally all I have to do is do the not exists part of this query. So I'm saying, give me all the serial numbers of active devices that are shipping telemetry, and when those devices do not exist in ServiceNow, that's it. I solved like $1 million problem doing that, because asset trackers want you to buy all these extra modules and products to do this, and it's a simple SQL query for us. And so to do that, again, I join the HR data, the MDM data, and the CMDB data from ServiceNow. Here's a kind of a bigger view of that query, right? And yeah, that's how we track when devices don't get at the asset tracker. And then we can cut a ticket. IT support or asset management will go fix it. The other problem we face in IT is, like, if you're familiar with AutoPKG does a ton of work for us, right? But how do you describe AutoPKG to like a director or a VP or a non-IT person? They're just like, I don't get it, whatever. And so you can take a lot of your automation from your CI environment and pipe it into Snowflake. And Streamlit is a Python framework that's built into Snowflake that allows you to build data applications in Snowflake. And so what we did was we took all the CI/CD data from GitLab, and we put it into a Streamlit app. And here it is. And so now I can go tell managers and other people, hey, go check out what my team is bringing to the table, right? And these Streamlit apps are interactive. You can have drop-down menus, input menus. It's a full-blown web application. And as you can see here, it shows all the packages that we're building each month. You can also go back and filter by year. You can filter by app or product, and those are the Chrome patches that we've automatically built with AutoPKG. And now I've taken this invisible back-end thing that no one understands but IT, and I visualized it. So these are all the labor hours we're saving by doing this. And then laptop performance data, right? My Chrome is eating too many RAMs, right? So we are collecting performance data. Arguably, this is new to us. We've only been doing it for a couple months. So I'm not going to be able to give you the full end-to-end picture because we're still going through our journey on performance data. But ideally, how you could do it is OS query. And that's how we do it. Now let's go look at some of the data we got. So picking on Google Chrome again. As remember, all the data pipelines, all the data modeling has paid off. That simple query that I wrote in the bottom corner allows me to look at Chrome's nastiest states across my fleet. And yes, that top one is taking 500% CPU time, 3 gigs of RAM, And I don't know what that bytes is. I haven't done the math, but it's doing a lot of disk I/O, right? And so you can track performance of like your security agents, your web browsers, things like that. And then you can kind of paint a picture of like, well, all right, you had bad performance, but it was only for like 5 minutes or an hour. Or you've had bad performance consistently for weeks. There might be a problem with your system. And this is the last part of this talk, and then we'll go into Q&A. So people in here use SaaS, use cloud, right? SaaS, you don't get host access by design, and that's a good thing because it's not your problem. It's the vendor's problem. But how do you track like what the application is doing with the SaaS, right? So again, we do all of our Jamf webhooks into a dashboard. So I can tell how many recons are happening per an hour, how many enrollments are happening per a day, how many API calls are happening. It looks like that account made 58,000 plus API calls to Jamf, right? I track that because previously the person that was doing the data pipeline to Jamf was doing like 400,000 API calls a day to Jamf, and that's just too many. And so you can use webhooks to kind of like webhook events like in Jamf to kind of track what your Jamf Cloud instance is doing health-wise without having direct host access. The key takeaways are basically everything I just said, right? So story time, when we had JSS Importer running before we scrapped that for Monkey, we had an API failure where a smart group and a policy object had mismatched versions of a package. That means the policy would install it, the smart group goes, that's the wrong version, and it would just recon and loop. And I generated over 100,000 recons in a few hours. If I didn't have that webhook monitor, I wouldn't have known. And that's it. Thank you for attending. Thanks to all the PSU staff. Thanks to the Mac Admin Foundation for everything they do. And I've added some useful links. You can try Snowflake for free, no strings attached, by going to that link. And I think we give you like $400 of Amazon credits for free. So go there, check it out. You can find me on Slack, find me on LinkedIn. I'm more than happy to help. And if there's any questions, we got 3 minutes.
I don't have a question. I have a shameless plug. Anybody interested in the things Tom's doing with Fleet, come down and talk to us at the
Thank you, Brock. All right. Well, if there's no question. Oh, yes. Oh, I think you have to do this.
To stop?
It should go.
No. First of all, you were talking about vulnerabilities, tracking vulnerabilities. Do you have any kind of database you ingest to join with processes?
Yeah, so we use...
sorry.
Oh, sorry. Go ahead.
And how do you do the match between the definition in the database with the vulnerabilities and the data you collect with OS Query?
Sure. So we use a product called Nessus from Tenable.
Yep.
And it has an agent, and so it runs all these plugins, which are essentially shell scripts. And it then escrows that data up to their product. They generate a report. We then ingest that entire report into Snowflake. And so it gives us like a serial number and all the vulns. And then so from there, we can do all the joining by serial number. Okay. And so that's how we get our vulnerability reports. I didn't share the vulnerability data on a slide because I didn't ask marketing and security and legal if I could. So I just left it out. Yeah.
Now it's just that usually when you take a public feed, you get like the definition of a product, but it's not directly applicable with a bundle ID, for example, or something like that.
Oh, yeah.
But then you have your product do the matching and then reporting directly with serial number.
Yeah.
And the second one is a bit more technical. It's about like a Snowflake. I've noticed in your blog that you ingest like raw data. Most of the time, just JSON is a blob that you can pass at query time or in the materialized view or stuff like that. But well, for us mortals that have to deal with a Snowflake bill, usually it's better to have, if I understand correctly, like a partition key so that you can.
Yeah.
So do you use at least a timestamp?
Yes. Yeah, that's a great question. So basically, we ingest a ton of data, and we use key clustering to keep it. And this is, I guess we're done here. To keep it basically from to be performant and not costly. And so we use serial number and date stamp, and so it's ingested raw, transformed into a table, but broken that out into columns, and that's how we do that.
This is it, yeah.
Yeah. Thank you.
Thank you.